Math 8, Unit 1, Lesson 5, Part 1, Solving Equations. Special solution types. Consider this equation. 6x plus 4 equals 4 times 3 halves x plus 1. Well, I've color-coded some things here since I'm not able to easily write. I start with the original equation. Now I've highlighted in kind of a bluish purple color the number 4. I'm going to distribute that. 4 times 3 halves is 12 halves. 4 times 3 is 12. And 4 times 1 is 1. I'm going to simplify that down. 12 halves is 6. 4 is 4. Don't need the parentheses anymore. So there we go, simplified. 6x plus 4 equals 6x plus 4. That seems kind of interesting. So I pick one of the x's. Let's pick this 6x. I'm going to subtract 6x from both sides. When I do something on both sides, I highlight that in red here so that it stands out. And then I'm going to simplify that. And I get 4 equals 4. That's kind of weird, because usually I get an x equals. So let's see what's going on here. We get 4 equals 4. So what's the solution? Well, let's use guess and check to see. We got 4 equals 4. Let's see if 4 works. So the original equation, I take the x's out and I replace them with 4. 6 times 4 is 24. Plus 4 is 28. And that's going to equal what's on the other side. That's 4 times, in the parentheses, we get 3 halves of 4 would be 6. 6 plus 1 is 7. 4 times 7 is 28. That's true. So 4 is the solution. Well, that's interesting. However, let's try another one. 0. 6 times 0 is 0, plus 4 is 4. 4 times 3 halves times 0 plus 1. So 4 times 3 halves is, 3 halves times 0 is 0. So this is just 4 times 1. Hey, that's also true. So 0 is the solution. So far we've found that this one has those two solutions. But wait, there's more. Let's try a negative 2 in. 6 times negative 2, that's negative 12. Negative 12 plus 4 is negative 8. Okay, let's try the other side out. We got 4 times 3 halves times negative 2 is negative 3. Negative 3 plus 1 is negative 2. So negative 8 equals 4 times negative 2. Well, that's also true. Oh. Does this mean there's 4 solutions? Or 3 solutions? Well, the 4, you can see where it came from. I just took it right out of the equation. But 0 and negative 2, I just seem to have pulled those numbers out of thin air, out of pretty much anywhere. What I claim to you is it doesn't matter what numbers I use, they will all work. Everything works. Every single number in existence will work. So in a situation like this, we would say that x can equal any number. Or we might say there's infinitely many solutions. Okay, that's new. That's something we haven't done before. Okay, let's consider this one. 3 minus 4x equals negative 7 minus 4x. Okay, we've got x's on both sides. First thing we do there is probably try to do something to get rid of one of the x's. Since it's minus 4x, let's add 4x to both sides. You can see I've indicated I've done it on both sides here. Now negative 4x plus 4x is 0, so that's going to be gone. And negative 4x plus 4x is 0. That's going to be gone. I get 3 equals negative 7. All right, I've got a similar situation that's happened here. in the course of solving, I no longer have an x. And the purpose of solving is to get x by itself to figure out what x can be. So we're going to not be able to do this in the normal way. So let's try some guess and check. Well, we got 3 and negative 7, so let's try 3. We tried that last time. Okay, 3 minus 4 times 3, that's 3 minus 12. And negative 7 minus 12. Okay, so this is, what would that be, negative 9. Let me try this again. It's going to be negative 9 equals negative 7 minus 12 is negative 19. All right, that's not true. So what that tells us is that 3 is not a solution. 3 is not going to be a solution to this. So let me just kind of cross it out if I can. So doesn't work. All right, let's try another one. What if we try the negative 7 that's there? Well, 3 minus 4 times negative 7. Negative 4 times negative 7 is 28. 3 plus 28 will be 31. And the other side, negative 7 minus 4 times negative 7. Negative 4 times negative 7 is 28. This is 7. Negative 7 plus 28, that's 21. Again, that is false. So 7 doesn't work. Will anything at all work here? Let's try 10. 3 minus 4 times 10, that's 3 minus 40. That's negative 37. Negative 7 minus 40 is negative 47. That's not true either. Okay, let's take a closer look here at these. Negative 9 equals negative 19. Well, negative 9 is 10 bigger than negative 19. 31 equals 21. Well, 31 is 10 bigger than 21. Negative 37 equals negative 47. Well, negative 37 is 10 bigger than negative 47. It looks like no matter what number I plug in, I will always get a number on the left side that is 10 bigger than the number on the right side. And in that case, they will never be the same. So this has no solution. There is no number in existence that we can plug in that will make this true. So it's no solution. So in the course of solving, if you get a false statement with no x in it, then it's not possible to make it true. Because when we're solving, we're trying to figure out what value will make the equation true. Let's just go over a couple more examples. 2x plus 1 equals 2x minus 1. All right. First thing, pick one of the x's. Let's get rid of it. So we'll subtract 2x from both sides. Here I've highlighted it in red to show I've done it on both sides. Now 2x minus 2x, that's going to be 0. And 2x minus 2x, that's going to be 0. I'm left with 1 equals negative 1. Now this is a false statement, so this one has no solution. Next example. 1/2 times 6t minus 4 equals 3t minus 2. Okay, first thing, highlighted in a bluish purple here, I'm going to do distributing. 1/2 times 6t minus 1/2 times 4, that'll give you 3t minus 2. And the other side's just 3t minus 2. Now this actually seems kind of strange at this point. We have exactly the same thing on both sides. In fact, when you notice the exact same thing on both sides, you can actually stop at that point because you'll know what the answer is. But let's finish up here. We would subtract 3t from both sides. Here I've again highlighted that in red. And then when 3t minus 3t is 0, so that's gone. I get negative 2. And then the other side I also get negative 2. Negative 2 equals negative 2 is true, and it's always true. So it does not matter what number we plug in. it will give us a solution to this equation. So t can be any number. Okay, 1/3 times 2b plus 9 is equal to 2/3 times b plus 9 halves. Okay, first I notice that there's some distributing that needs done. So we're going to distribute 1/3 here, and we're going to distribute 2/3 here. 1/3 times 2b plus 9 will be 2/3 b plus 9/3. And 2/3 times b is 2/3 b. 2/3 times 9 halves, well, 2 times 9 is 18, and 3 times 2 is 6. Okay, I've highlighted here in green. These need simplified. So we're going to simplify them. We get 2/3 plus 3 equals 2/3 plus 3. Right now, you'll probably notice that they are equal to each other. But if we go ahead and subtract the 2/3 b from both sides, then we get this is 0, 2/3 b minus 2/3 b. And 2/3 b minus 2/3 b here is also 0. We're just left with 3 equals 3. And since that is true, b can be any number. Okay, let's look at the next example. 6 times 5 minus 2v equals negative 4 times 3v plus 1. Now with the parentheses, we'll of course want to distribute the 6 into the parenthesis on the left and negative 4 into the parentheses on the right. 6 times 5 is 30, and 6 times negative 2 is negative 12. Negative 4 times 3 is negative 12 with a v. Negative 4 times 1 is negative 4. Next, we've got a v on both sides, so let's pick one of them. Negative 12v, and we'll add 12v to both sides. And here I've indicated it in that little pink box. Now negative 12v plus 12v is going to be 0, so that's going to disappear. So will that. That gives me negative 30 equals negative 4. That is false. Therefore, there is no solution here. Okay, that's the end of the first video. The second video will include the notes.